Great. Thanks a lot, and thanks for having us here at this event. We're going to very quickly present a series of research projects and kind of an approach to architectural research, which is open source, incremental, and in some senses small scale, but we feel that it definitely engages the city and kind of the theme of the event here. Our practice is called The Living. We're going to talk a little bit about the research process first, and some of this is documented in a book, a pair of books actually, that we published recently called Life Size.
And the kind of research methodology that we developed, what we call flash research, is a project, an architecture project that involves a budget of under $1,000, a duration of less than 3 months, and a full-scale functioning prototype as a proof of concept. The flash research projects that we're going to present each have a lifespan, which of course starts at 3 months by definition, but can expand in kind of a open loop system. So the loop of 3 months connects to another loop of research by other people, and by further research by ourselves. So each project has a longer lifespan than 3 months. And the graph on the left basically shows the scale that we operate at, most of which is full scale, and from time to time it involves scaled models as well.
And finally, about the flash research, we considered that our own project, a single flash research project, involves this kind of looping back and forth between a hypothesis, then building a functioning prototype to test the hypothesis, and then building some instructions, basically documenting what we've done so that other people can kind of pick up where we left off and take it in different directions. So that's kind of what's going on the left-hand side. And on the right-hand side, we consider this research to be very much connected to research that's happened both before we came along and hopefully after we leave off.
So the first project we're going to present is called Living Mass, and it starts off with a question: what if architecture responded to you?
And one of the first things we did when we started this project was commit to using a material called a shape memory alloy, which is a thin wire that contracts along its length when you apply electricity to it.
So here are the first, we'll try to go through very quickly, but these are the first 2 prototypes that we've built using shape memory alloy wires.
And here, the next 2 prototypes, we're basically having a shape memory alloy contract and cause a series of movements and even pattern of movements controlled by a simple microcontroller.
Here is prototype 4 and 5, or 5 and 6. We started using infrared sensors on the left, and on the right started focusing on making a surface that can respond to the tempo of breathing.
And at this point, we engaged in a series of experiments with different skins. We knew at this point we honed down on the idea of using a kind of movable skin as our application of this shape memory alloy. And we tested a series of different materials and patterns of slits in the materials, including plywood, plastics, and eventually cast silicone with the wires inside.
Here is the next prototype, which we embed the shape memory alloy wire in a cast silicone.
And the next series of prototypes is basically involves different patterns of movement. On the left-hand side is using a kind of thickening of the material to cause a certain movement, and on the right-hand side we're cutting what we think of as gills into the surface to cause a kind of opening and closing when the wire contracts.
So here's the final proof of concept prototype that responds to the presence of people and opens up when people approach the surface to let fresh air in. And so as kind of a summary of this project, we're basically defining responsive kinetic architecture to involve input, processing, and output. Input meaning some kind of sensor. In this case, in the first round of our flash research, we used an infrared sensor, but other sensors could be used. Processing through a simple microcontroller, the basic stamp, and output through the opening and closing of these gills via the Flexinol wire.
And here are some of the unique characteristics that we identified, which are the movement itself involves no motors or mechanical parts. It's silent and it's thin, it's transparent, and aesthetic, and the movement itself is very organic. So, like David briefly mentioned before, after the initial research, we were commissioned by Chicago Museum of Science and Industry to produce a kind of more developed prototype, and David is going to demo that prototype. And then David's going to breathe into the CO2 sensor on the side, and the gills are going to open up, responding to the presence of CO2. So the idea is to the movement itself of the surface itself could be information revealing the presence of high level of CO2, but it also opens up to ventilate the space, kind of providing immediate solution to the problem that's been identified. And the next project we'll present is called River Glow, and it starts off with the question, what if architecture produced its own energy?
And what we did first when we started here, as usual, we got right into some prototypes, and we're testing here a solenoid on the left, basically putting a magnet through a coil, and on the right a kind of new material called electroactive polymer, which both generates energy when you move it, and when you give it electricity, it moves.
And here is another prototype testing out thin, flexible photovoltaic cells.
And at this point, we knew that the amount of energy that we could harness from architecture, from the environment, was a small amount. But rather than be discouraged at that point, we decided that we would look for output that was correspondingly small. So we collect a micro unit of energy, and then we spend a micro unit of energy. And this is electroluminescent sheet, which is lighting that requires very little amount of energy.
So this is a brief diagram of the final prototype that we made.
And we don't get too technical in our projects, but we did enough energy calculations to prove that we would be able to harness energy and spend it at a kind of equivalent ratio.
So here are some detailed views of the initial proof of concept prototype.
And here we are testing the full-scale prototype in Soo-in's bathtub.
And again, we identified unique characteristics of the project, which are energy self-sufficient, it's collecting and using microunits of energy, and it provides immediate interface to water quality to the public.
And just like the last project, there was a phase of research after the initial 3 months of flash research. And here we were asked to demonstrate the prototype at Innovation Lab in Copenhagen. So we developed a slightly new prototype, which Soo-in is going to attempt to live demo. To give ourselves the challenge, if we're going to claim we make prototypes, then we better demo them for you, a live audience. And it's basically, you can go ahead and start. It's basically got a pH sensor, which now we're putting in a cup of water, but ideally would be hanging in a canal or a public body of water. And it's basically sensing the quality of a public body of water in a low-tech way. It's not a substitute for more high-tech, more comprehensive testing that's often off-site in the lab, but we believe that